Welcome. If you're preparing for competitive exams, mastering number systems is a must. In this video, we'll break down essential formulae, powerful theorems, and lightning-fast shortcut techniques. These tools will help you solve number system problems faster and smarter. Whether you're facing sums, remainders, or tricky patterns, you'll gain the confidence to tackle any question. Let's dive in and start building your toolkit for exam success, one concept at a time. Ready to transform your approach and save precious time in every test? Let's get started with the foundational formulae every aspirant should know. Let's begin with the sum formulae for natural, even, and odd numbers. These are the backbone of many number system problems. The sum of the first n natural numbers is given by n plus 1/2. For the first n even numbers, use n plus 1. And for the first n odd numbers, it's simply n squared. These formulae allow you to quickly calculate totals without adding each term individually. For example, the sum of the first 10 natural numbers is 10 times 11 divided by 2, which equals 55. Memorize these and you'll breeze through basic sum questions. See these sum formulae in action. Suppose you're asked for the sum of the first 10 natural numbers. Plug in n equals 10, 10 times 11 divided by 2 equals 55. For the first 5 odd numbers, use n squared. 5 squared is 25. These quick calculations save valuable time during exams. Practice with different values of n to build speed and confidence. The more you use these formulae, the more automatic they become, allowing you to focus on tougher problems. Next, let's cover square and cube identities. These algebraic shortcuts are crucial for simplifying expressions and solving equations quickly. The square of a plus b is a 2 plus 2 ob plus b2. The cube of a plus b is a 3 plus 3 a 2b plus 3 ob 2 plus b3. Also remember the difference of squares. A 2b2 equals a plus b, ab. These identities help you expand and factor expressions in seconds, making complex calculations much more manageable. Let's move on to theorems that make solving number system problems a breeze. The remainder theorem, Euler's theorem, and Fermat's little theorem are your best friends for division and remainder questions. These theorems reveal patterns and shortcuts that let you solve what would otherwise be lengthy calculations in just a few steps. Understanding when and how to apply each theorem is key to maximizing your efficiency in exams. Remainder theorem helps you quickly determine the remainder when a number is divided by a divisor. It's especially useful for polynomial expressions and large numbers. By understanding the predictable patterns of remainders, you can instantly solve division questions that might otherwise take several steps. This theorem is a must-know for anyone aiming to score high in competitive exams. Euler's theorem is a powerful tool for finding remainders of large powers, especially when the base and the modulus are coprime. It simplifies complex calculations by reducing the size of the exponent, making it extremely useful in competitive exams. Mastering this theorem will allow you to handle advanced remainder problems with confidence and speed. Fermat's little theorem is essential when working with prime numbers. It provides a shortcut for calculating remainders of exponential expressions, especially when the modulus is a prime. This theorem is a staple in number theory and can save you significant time during exams. Practice applying it to different problems to see how it simplifies calculations. Now let's unlock some shortcut techniques that will help you solve questions in seconds. These tricks, when mastered, can turn lengthy calculations into quick mental math. From unit digit tricks to digital root methods, each technique is designed to save you time and boost your accuracy. Practice is key. Use these shortcuts regularly to make them second nature. Unit digit tricks are incredibly useful for finding the last digit of large powers. By recognizing cyclicity patterns, you can instantly determine the unit digit without calculating the entire number. For example, the unit digit of 3 raised to any power follows a repeating cycle, 3, 9, 7, 1. Knowing these cycles lets you answer unit digit questions in seconds. Sometimes, you need to find the last 2 digits of a large number. Advanced techniques like using modular arithmetic or patterns can help you solve these quickly. By breaking down the calculation and focusing on the last 2 digits, you avoid unnecessary work and get to the answer faster. Practice with different examples to master this skill. Number cyclicity is the concept that digits repeat their unit digit in a specific cycle when raised to increasing powers. For example, 2, 3, 7, and 8 have a cycle length of 4, while 4 and 9 have a cycle length of 2. By dividing the exponent by the cycle length, you can instantly find the unit digit. This trick is a game changer for power-based questions. Let's look at the cyclicity table for digits 0 through 9. Some digits like 0, 1, 5, and 6 always end with the same unit digit, so their cycle length is 1. Others like 2, 3, 7, and 8 have a cycle length of 4. Understanding these cycles allows you to quickly determine the unit digit of any power, making calculations much faster and more reliable. Let's apply cyclicity with a quick example. What's the unit digit of 3 raised to the 11th power? The cycle for 3 is 3, 9, 7, 1, repeating every 4. Divide 11 by 4, the remainder is 3, so the third number in the cycle is 7. The unit digit is 7. This method works for any digit in any power. Just find the cycle and use the remainder. Digital root method is a quick way to check divisibility and verify answers. Add all the digits of a number repeatedly until you get a single digit. This single digit, the digital root, can reveal divisibility by 3 or 9 and help you spot calculation errors. It's a simple yet powerful tool for quick checks during exams. Casting out nines is an ancient technique for verifying calculations. After finding the digital root of your answer, compare it to the digital root of the original numbers. If they don't match, there's a mistake. This method is especially useful for checking multiplication and addition problems quickly, helping you avoid costly errors. To check if a number is prime, test divisibility by all primes up to its square root. If none divide it, the number is prime. This method is much faster than checking every possible divisor. It's especially useful for large numbers, helping you quickly identify primes in exam questions. Finding the least common multiple (LCM) and highest common factor (HCF) can be quick if you use the right method. Use prime factorization or the formula. LCM times HCF equals the product of two numbers. Choose the method that's fastest for the numbers you're given. With practice, you'll be able to solve these in seconds. Modulo arithmetic is the backbone of many competitive exam questions. It's all about finding remainders after division. Once you understand the basic rules, even complex problems become much easier. Let's break down the key rules for addition, multiplication, and powers under modulo. The addition rule in modulo arithmetic states that a plus b mod n equals the sum of their individual remainders. Mod n, this means you can break down large sums into smaller, manageable parts, find their remainders, and then add them up. This rule is especially helpful for simplifying big calculations. Similarly, the multiplication rule says a times b mod n equals the product of their individual remainders. Mod n, this allows you to break down large products into smaller pieces, find their remainders, and multiply them. It's a powerful way to simplify calculations and avoid large numbers. The power rule lets you break large powers into smaller parts using the multiplication rule repeatedly. This is especially useful for questions involving exponents. By reducing the size of the numbers at each step, you can quickly find the remainder without getting bogged down in huge calculations. Divisibility checks help you quickly determine if a number is divisible by another. For example, a number is divisible by 2 if its last digit is even, by 3 or 9 if the sum of its digits is divisible by 3 or 9, by 4 if the last two digits are divisible by 4, and by 5 if the last digit is 0 or 5. These rules are quick to apply and save time in exams. Sometimes you might get a negative remainder when using modulo arithmetic. Don't worry, just add the divisor to your result until you get a positive number less than the divisor. For example, minus 7 mod 5, add 5 to get minus 2, then add 5 again to get 3. The correct remainder is 3. Always remember the remainder should be non-negative and less than the divisor. Let's recap some common divisibility rules. By 2, last digit even. By 3 or 9, sum of digits divisible by 3 or 9. By 4, last two digits divisible by 4. By 5, last digit 0 or 5. By 11, difference of alternate digit sums divisible by 11. These quick checks help you spot factors and simplify problems instantly. Pattern-based questions are common in competitive exams. They test your ability to spot arithmetic, geometric, or special patterns like squares, cubes, or primes in a sequence. Recognizing these patterns quickly is key to solving these questions efficiently. Let's explore some strategies for tackling pattern-based problems. When faced with a missing number in a sequence, look for common patterns. Is it an arithmetic progression, geometric progression, or a series of squares or cubes? Sometimes the pattern involves alternating operations or special numbers like primes. Practice identifying these patterns to solve missing number questions quickly. Series questions often involve recognizing properties like the Fibonacci sequence, triangular numbers, or the difference between consecutive terms. Understanding these properties helps you predict the next number or find the missing term. The more series types you practice, the faster you'll recognize them in exams. To get better at pattern-based questions, solve at least 20 pattern problems daily. This consistent practice will train your brain to recognize patterns automatically. Over time, you'll develop an intuition for spotting the logic behind sequences, making these questions much easier to tackle during exams. You've now learned essential formulae, powerful theorems, and shortcut techniques for mastering number systems. With regular practice, these tools will become second nature, giving you a competitive edge in exams. Remember, speed and accuracy come from understanding and applying these concepts consistently. Effective time management is crucial in competitive exams. Use the shortcuts and formulae you've learned to solve easy questions quickly, leaving more time for challenging problems. Prioritize questions based on your strengths and the marks they carry. With practice, you'll develop a strategy that maximizes your score. Watch out for common mistakes like misapplying formulae, forgetting to check remainders, or missing patterns in sequences. Always double-check your work, especially for negative remainders or divisibility rules. With careful practice, you'll minimize errors and boost your confidence in exams. Speed comes from consistent practice. Set aside time each day to solve number system problems using the techniques you've learned. Track your progress and challenge yourself with timed quizzes. The more you practice, the faster and more accurate you'll become. Let's quickly recap the key formulae: sum of natural numbers, even numbers and odd numbers, square and cube identities, and the difference of squares. Keep these at your fingertips. They're the foundation for solving a wide range of number system questions efficiently. Remember the key theorems: remainder theorem, Euler's theorem, and Fermat's little theorem. Practice applying each one to different types of problems. Understanding when to use each theorem is just as important as knowing the statement itself. Don't forget the shortcut techniques: unit digit tricks, digital root method, casting out nines, quick prime checking, and fast LCM HCF tricks. These methods are designed to save you time and reduce calculation errors. Make them part of your regular practice routine. The key to mastering number systems is consistent practice. Set a goal to solve a certain number of problems each day, focusing on different techniques. Over time, you'll notice patterns and shortcuts becoming second nature, making you faster and more accurate. As you master these techniques, your confidence in tackling number system questions will grow. Confidence comes from preparation and familiarity with different question types. The more you practice, the more comfortable you'll feel during exams, leading to better performance. Challenge yourself with mixed problems that combine formulae, theorems, and shortcuts. These questions test your ability to choose the right technique for each situation. The more you practice mixed problems, the more flexible and adaptable you'll become in exams. Keep a record of your practice sessions and scores. Tracking your progress helps you identify areas for improvement and celebrate your achievements. Set milestones and reward yourself as you reach new levels of speed and accuracy. Staying motivated is key to long-term success. Remind yourself of your goals and the benefits of mastering number systems. Join study groups or find a practice partner to keep each other accountable. Motivation and consistency go hand in hand. On exam day, stay calm and trust your preparation. Read each question carefully, apply the appropriate technique, and double-check your answers if time allows. Remember, you've built a strong foundation. Now it's time to put your skills to the test and shine. To continue improving, seek out additional resources like practice books, online quizzes, and mock exams. The more exposure you have to different question types, the more versatile you'll become. Make use of every resource available to you. Take a moment to celebrate how far you've come. Mastering number systems is a significant achievement, and your hard work will pay off in your exam results. Keep practicing, stay positive, and remember that every step forward brings you closer to your goals. Congratulations! You're now equipped with powerful formulae, theorems, and shortcut techniques for mastering number system problems. With regular practice and the right mindset, you'll approach every exam with confidence and speed. Keep refining your skills and success will follow. Good luck on your journey to exam excellence.